Welcome back, guys. Now we're gonna be doing radioactivity and the nuclear atom. Question 6 to 10, paper 1, 5054. Let's start. Question 6. The light emitted from a galaxy is redshifted and when detected on Earth. How does the frequency of the light frequency का पूछ रहे detected on Earth compare with the frequency when emitted and in what direction? दोनों ने हमसे दो सवाल पूछे हैं कि what will the frequency be? Will it be greater or will it be lesser? And in which direction is it moving? Right? So सबसे पहले हम बात करें when the light from a galaxy is redshifted. जब एक लाइट होती है from a galaxy that is redshifted, it automatically means that the frequency of the light is lower than the frequency at which it was emitted. Redshift जो होती है ना, that only occurs when the galaxy is moving away from the earth, right? अगर हमारे planet और एक galaxy है, right, it is moving away from the earth, that is only when the redshift will occur. समझ आ गई? And causing the light to stretch. It will stretch the light, and when you stretch the light, it will increase the wavelength. And when it increases the wavelength, जब wavelength ऊपर जाएगा, the frequency नीचे जाएगी, ठीक है ना? And yeah, when the wavelength increases, the frequency will decrease. अच्छा, अब हमने क्या दो चीजें determine की हैं कि जब redshift होता है, that means it is moving away from the earth, right? And the second thing that we determined was that the frequency is decreasing since the wavelength is increasing. So frequency is reducing and it is moving away from the earth. So A will be the clear cut answer. Acha, question 7. It is an experiment. Alpha particles are fired at a thin gold sheet. Most alpha particles pass straight through the thin gold sheet. You have to keep that in mind. And a few are deflected. What can be deduced from this experiment? So, for example, you have a huge area in which you only have a small nucleus, right? And आप इसकी तरफ fire कर रहे हो alpha particles, right? Alpha particles fire कर रहे हो, इसको in 2D बनाते हैं, ठीक है ना? For example, this is the and this is our nucleus, right? And alpha particles are passed through the atom, right? They're saying that most of the particles pass through the gold sheet, right? तो ये सारे pass हो रहे हैं from through the gold sheet, right? अब यहाँ क्या होगा? जब alpha particle hit करेगा nucleus को, what will happen? What will happen is that the alpha particle will deflect, right? In whatever way. एक और particle ने hit किया है, it will deflect again, और ये बाकी के particles are still passing right through the gold sheet. So what this experiment is stating that most of the atom is empty space and the alpha particles can like pass right through the gold sheet since the atoms are mostly empty space and the nucleus is very small, therefore all the mass is concentrated in one area which is the nucleus. न्यूक्लियस में सारा mass है और बाकी का जो atom है ना, that is फारिग, that is not occupying any space, therefore everything is passing right through the atom, right? So A will be the answer. The nucleus is very small, therefore only a few particles are deflecting. The nucleus has no charge, that does not matter. Electrons surround the nucleus. The electrons have a negative charge. No, I mean they do, but not in this situation. It is not relevant. आगे देख लेते हैं क्वेश्चन 8. क्वेश्चन 8 में हमें बोला गया है थ्री टाइप्स ऑफ रेडिएशन emitted by unstable nuclei are helium nuclei, short wavelength electromagnetic waves and electrons. So what are these three type of radiations? ठीक है ना? पहले हमें बताया गया हीलियम न्यूक्लियाई. हीलियम न्यूक्लियाई हमारे पास कौन कौन सी थ्री टाइप्स ऑफ रेडिएशन होती हैं? इट इज द अल्फा, इट इज गोना बी द gamma and the beta. The beta is negative, right? the gamma is neutral, and the alpha is positive. समझ आ गई? So straight away the answer should be what? A, right? So yeah, let's move on. Question 9. Which statement about all three types of radioactive emissions is correct? They are all absorbed by a thin aluminum sheet. They are not all absorbed by a thin aluminum sheet. Only like rest of the two are, but gamma isn't. Gamma isn't absorbed by the thin aluminum sheet. B. They are all deflected by electric fields. Again, gamma isn't deflected by the electric fields. They are all deflected by magnetic fields. Again, gamma isn't. So that leaves us with D, that all of them cause ionization of gas. ठीक है ना? have now we have that out of the way. आगे देख लेते हैं question 10. What is meant by the half-life of a radioactive substance? The half-life of a radioactive substance is the time it takes for the number of nuclei in a sample to decrease by half, right? तो when we say कि जो radioactive चीजें होती हैं, we shouldn't throw them away in the oceans and stuff, right? That is because उनकी half life जो होती है, that is in the millions, billions of or hundreds and thousands of years. It won't decay, it won't, right? Half life उसकी millions of years है, right? एक चीज है आपके पास, and for it to decay and for it to be left, like half of it to be left, आपको कितने साल लगेंगे? Millions of years लगेंगे. So is it a wise decision for us to do that? It is not. So that is why we highly condemn that radioactive materials should not be thrown into the oceans or landmines जो भी होते हैं, right? So yeah, so it is gonna be the time it takes for the nuclei to have half the time of unstable nuclei to decay, half the time it takes an unstable nuclei to emit radiation. No, half the time the unstable. अच्छा ठीक है, ये this looks like the say looks like the right answer. Let's check. Question 10 C. Question 10 C is the right answer. So yeah, that is gonna be it for this video. I hope you enjoyed. Have a great day. Allah Hafiz.